In section 28, we will look at exponential functions. The use of the calculator is required for this section. So given the function f of x is equal to 2 to the x, we're going to calculate f of -1, f of 0, and f of 2. And in each case, what we're doing is we're changing the x to the value that's in the parentheses here. So in the case of number 1, we're going to have 2 to the negative first. Now we know we're not allowed to have a negative exponent, so we would right away want to flip that fraction and make it 1 over 2. For the second one, if I've got 2 to the 0 power, anything to the 0 power is going to turn into 1. And for the third one, if I've got 2 squared is going to give me 4. So those should be the answers to numbers 1, 2, and 3. Next, we look at this function. If g of x is equal to 2 to the negative x plus 1. Well, here, if I'm calculating g of -1, I'm plugging a -1 in for this x. That's going to make this 2 to the negative first, which is really 2 to the first, and that's 2 plus 1. We're going to get 3 for this first one. For number 5, if I'm plugging in 0 here, it's 2 to the -0, which is really just 2 to the 0. That's going to give us 1. 1 plus 1, we're going to get 2 for this one. And then finally for g of 2, when we plug that in, I get 2 to the -2. Again, the negative exponent is going to make that flip, making it 1 over 2 squared, which is really 1/4. And then 1/4 plus 1 is going to be, we're thinking of that 1 as 4 over 4 because it's still equivalent to 1, but would have common denominators with 1/4, and that's going to give us a final answer of 5/4 for that. And then for this function, h of x is equal to 3 to the x minus 2. Here, if I'm plugging in that -1, I've got 3 to the negative first. That's going to give me 1/3, and then minus 2. Now again, I want to get common denominators here. So I'm going to have to think of 2 as being 6/3. So now if I've got 1/3 minus 6/3, I'm looking at -5/3 as my answer. For number 8, when I'm plugging in 0, 3 to the 0 power is 1. 1 minus 2 is going to give us -1. And then finally with 2, if I've got 3 squared, that's 9. 9 minus 2 is going to give us 7. So those are going to be the answers to 7, 8, and 9. Next, we're going to do something similar, but now this time we're reading a table. So here, if they're telling us to find s of 0, well, that's telling us that we want what's in the parentheses, which originally was t, to become 0. So what we'll do is look at the t values, and we go to 0 for that, and whatever its corresponding value is going to be our answer. For s of 0, that's then going to be 1. For s of 2, we go to 2. That answer is going to be 9, and for s of 4, we go to 4 here, and that answer is going to be 81. So those are our answers here. Next, looking at this table, again, I'm going to go to 0 right here, and that answer is going to be 2. Next, I look at v of 2. That answer is associated with 5. And then for v of 4, my answer is going to be 17. And then for this last table, when I'm looking at a of 0, once again, I'll go to 0 here. That answer is going to be 16. Then a of 2, I go to 2 here. That answer is going to be 1. And then for a of 4, I go to 4 here. That answer is going to be 1 over 16. So those should be our answers with the tables. Now we're going to interpret based on their graphs. So for this first one, if I'm looking for s of -1, that's going to be a t value, which is going to be along this axis right here. So I'm going to go to -1, and I'm going to approximate what the solution is. I'm going to say that that looks to be approximately 1/2. Now, if I was given a function in this one, I would definitely plug that -1 into the function for t and get an exact answer, but based on what I can tell here, it does look like it's at about 1/2. At 0, it appears to be at 1, and at 1, it looks like we're at +2. So those will be the answers for that graph. Next, with this one, if I'm looking at -1, at -1, I go up here, I'm at +1. At 0, it's intersecting at 0, so my answer is 0 there. And then at 1, it looks like we're down here, and that I'm going to approximate to be -1/2. And so this right here is a typo. At +1, this should be -1/2. Over here for -1, I'm going to be up at +1.5, which I'm going to call that 3/2. For a of 0, I'll be at 2. For a of 1, that's going to be at 3. So those are going to be my answers for this one. When we look at this next one, we can use the tables in the calculator to do this, or we can calculate this using the calculator still, but just individually typing these in. So whichever method you think is going to be easier for you. In section 26, we talked about how to type this in. We would type this in for y sub 1. And we would set up our table accordingly, and then we would just interpret the graph to answer 7, 11, and 15. But I would argue that it might actually be easier for us to type these in individually. Here, if I type in 2 times 1.3 to the 7th, and I get my answer here. Then if I type in 2 times 1.3 to the 11th, and finally 2 times 1.3 to the 15th. And then it says to round to 3 decimal places, so these are going to be our answers for 28, 29, and 30. So again, with the next one, I could start by writing this in or typing this in to y sub 1. I could adjust my table accordingly, or I could just plug those values in. So if I plug in a -2 here, then I'll plug in a 0 here, and then finally I'll plug in a 2 here. And these are the answers that I should get. And then finally for this last one, same thing. Type it into y sub 1 if you would like, or you could just plug in the numbers. So with this one, if I'm typing in 1.1 times 2.7 to the first, and then I would change that 1 to a 3, and finally to a 5. And those should be the answers for 31, 32, and 33. We have a few more that are going to be very similar to that, so we'll go ahead and try 34 through 36. And no matter which method you're using, our answers should be these answers that you see here. You'll try 37 through 39. And whether you typed that in for y sub 1 and read the table, or if you simply just plugged each of them in, those should be our answers for this one. And then finally for the last one, you can go ahead and plug those in, and these should be the answers for 40 through 42. Now for this first one, I'm going to go ahead and put the answers up, and I'm going to describe this as I go through. So first of all, vertical intercept, that's going to be vertical meaning vertical axis, intercept meaning where that crosses. And so this one crosses right here, and that's at +1. Next, when I'm looking for the zeros are where the graph is going to cross over the x-axis. And in this case, it doesn't ever touch the x-axis. That can be a little bit hard to interpret. When we're looking at this right here, it does look like it's touching it, but because we have this dotted line right here, that's going to be our horizontal asymptote, which means nothing can touch that. From here, if I'm looking at increasing versus decreasing, you're always going to read this from the left going to the right. And so if from the left going to the right, just like I would read a sentence, it is going up. And that's why this is considered increasing. If it's increasing, it's going to be considered growth. If it was decreasing, it'd be considered decay. Then for the end behavior, we've talked about this before. On the left side, the negative infinity side, we're looking over here, and we're looking at what are these values going towards, and they're going towards that asymptote there. That asymptote then is at 0, so that's what the values are all approaching. Then on the right side, if I look at where that's going, that one, if I were to put an arrow on that, is going up forever. So that one is approaching positive infinity. Then finally, when they're looking for a horizontal asymptote, what we should put on the left here is going to match up with the function. So a lot of times when we talk about a horizontal line in the past, we've described that as like y equals a number. But in this case, it's not y equals, it's f of x equals. So we're going to do f of x equals, and it's whatever it's passing through on this f of x axis. In this case, it's going to be at 0. So I want you to do as much as you can with number 2, filling in any information that you can fill in. So again, if I'm looking for the vertical intercept is going to be where our graph passes through the vertical axis, and in this case, it's going to be at 4. The zeros here, it never crosses over the x-axis, so we're going to say none as far as zeros. As far as increasing or decreasing, if I start to trace this, it is going down forever. If I start to trace this left to right, it is going down, so that's decreasing. And we said before that if it's decreasing, it's going to be decay. Then as far as my end behavior, again, this indicates the left side, so I'm looking over on the left side. And if I were to put an arrow on this, it's going up forever. So that's approaching positive infinity. Then as I look on the right side, it's going towards this asymptote here. This asymptote is at 1, 2, 3, and that's why this is going towards 3 here. Then finally, our horizontal asymptote, again, I'm looking at what's on the left here, that's f of x. It equals whatever it passes through right here, and that's going to be 3 in this case. So try number 3 now. And again, if I'm looking for a vertical intercept here, it appears to be right here. And I would say that this looks like it's at -1.5 or -3/2. And that's what I'm going to go with for my vertical intercept. As far as the zeros, again, that's going to be where it crosses over the x-axis. And it's crossing right here, and that's at +2. Then in terms of increasing or decreasing, again, we're going to look from left to right. It's going up, therefore increasing, and therefore growth, since those are going to go together. End behavior, if I look at the left side, it's going towards the asymptote here. This asymptote is passing through f of x at -2. So that's going to be what its end behavior would be on that side. And then on the right side, I can see that this is going up forever. So that's going to approach positive infinity. Then finally, for the horizontal asymptote, here we're going to do, again, f of x equals, and since it's passing through -2, that's where we're going to get f of x is equal to -2. Try number 4. And for number 4, it might be a little bit hard to interpret based on this graph where a vertical intercept is. So if you couldn't tell where it is, maybe we're guessing, is it at 6 or is it at 7, or is it in between those values somehow? What we might consider doing then is plugging in a 0 for our x value and seeing what we get here. Well, if I plug in a 0 here, I've got 0 minus 2, that's -2. Well, 1/3 to the -2 is first of all going to make that flip, and then it's 3 squared, which is going to turn into 9. And 9 minus 3 is going to be 6. So that confirms that it does pass through 6. From there, for the zeros, it appears to be right here, which is at 1. As far as increasing or decreasing, this one is going down over time. So that's going to be decreasing and decay. Then on the left side, again, I'm on this side, I'm looking at where my arrow would point, and that would go up forever, so that's going to go to positive infinity. Then if I look at the right side, it's going towards the asymptote, and that asymptote is at -3. Then finally, for the horizontal asymptote, we're going to say f of x equals, and then because that dotted line is going through at -3, that's where my horizontal asymptote will be. Try number 5. And on this one, it looks like the vertical intercept is going to be at +4. For zeros, we won't actually have any zeros here. It never crosses. It does appear to be increasing from left to right, which means it's also growth. On this side, it's going towards the asymptote. That asymptote is at +1. Whereas on this side, if I put an arrow on that, it's going up forever, which means it's approaching positive infinity. Our horizontal asymptote is f of x equals, again, because of this notation. And then since it's passing through the f of x axis at 1, that's where we're going to get f of x equals 1. Try number 6. Now 6 is another example of one where it might be a little bit hard to interpret where exactly this is crossing. So again, it might be wise for us to go ahead and plug in a 0 for x here and see what we get, and that will represent the vertical intercept. So if I did 1/4 to the 0 plus 2, that's 1/4 squared. Well, 1/4 squared is going to give me 1/16. Then if I'm doing 1/16 plus 2, we would then get 2 and 1/16. And that should make sense as far as where this point crosses. It's like a little bit above the 2 there. But in terms of what we want to write here, if we're thinking about adding 2 and 1/16, we do need to get common denominators. So I'm going to have to turn this 2 into 32/16, because then it's still equivalent to 2 but has the correct denominator we want. And then if I did 1/16 plus 32/16, that's where I get 33/16. Again, this one doesn't cross the x-axis at all, so that's going to be none for the zeros. If I trace this, it is decreasing over time, which means it's also decay. On the left side, if I put an arrow on this, it's going up forever, so positive infinity. And then on the right side, it is going towards this asymptote, which is at 2. Finally, for the asymptote, we're going to say f of x equals, and it passes through positive 2 right here, so we're going to go ahead and put f of x equals 2. Try this one. And on number 7, as far as the vertical intercept, again here, it might be a little bit hard for us to read. Maybe it's at 9, maybe it's at 10, maybe it's somewhere in the middle. So here's where, again, I'm going to plug a 0 in for x. So this becomes 4 squared, which is 16. 16 minus 4 is going to give us 12. So our vertical intercept didn't even show up on that graph. So we definitely needed to check that value. As far as our zeros, it does appear that that 0 is going to be right here, which is at -1. It is going to be increasing over time, and that's also going to represent growth. And then as far as our end behavior, on this side, it's going towards this asymptote, and that asymptote is at -4. On this side, if I put an arrow on that, it is going up forever, so that's going towards positive infinity. Finally, the horizontal asymptote is going to be where it crosses through the f of x axis, and that's going to be at -4. So we get f of x equals -4. What we want to do next is we want to try to come up with some conclusions based on that. One thing we're looking at is when will we have zeros and when will we not have zeros? Well, here's some examples of ones that ended up with zeros. Here's some examples of one that did not have zeros. So you want to kind of come up with a conclusion based on that. And basically what we want to notice here is that if they have negative numbers here, or if I can think of it as if we're subtracting a constant here, then we're going to have a 0. If we're not subtracting a constant here, we're not going to have a 0. For the next one, if we look at when we're going to have increasing or growth versus decreasing decay, what we want to notice here is the base of our exponent. So here I've got 2, 2, 3, and 4, and those all produce increasing or growth. But over here, when I had fractions as my base, those were all going to give me decreasing or decay. As far as our horizontal asymptotes, each asymptote is written next to the function that it came with, and so we want to, again, kind of draw some conclusions. We want to think, well, this 0, how did that come up from this equation? Then if I look at the 3, well, that's right here. The -2 is right here. This -3 is right here. Same thing holds true on this side. So the thing with this one is that we could have written this as 2 to the x plus 0. So basically that constant that we have at the end, whether positive or a negative, is going to be our horizontal asymptote. So with that information in mind, now we want to try to fill all of this in without looking at the graph of it. So first of all, for the vertical intercept, what we'll do is plug in a 0 for x. That's going to give me 5 to the first, which is still 5, and 5 minus 5 is going to be 0. So that is going to be my vertical intercept. From there, when I'm looking at my zeros, well, I just got that a point passes through 0, and that's going to be at 0, 0. So my 0 in this case is going to be at 0. As far as increasing or decreasing, because this base is at 5 and it's not a fraction, this is going to be increasing. It's also going to be growth then. Now, if we can picture that this is increasing, then I know that on the right side, it's going towards positive infinity. And then these two right here are going to have to match up. Whatever I get for the asymptote is going to be what this side is approaching. And our asymptote here is going to be f of x is equal to -5. Therefore, this one is going to approach -5 on that side. Now for number 9, here again for the vertical intercept, I want to plug in a 0 for x. If I do 0 minus 2, I'm going to get 6 to the -2nd. That's going to be 1 over 6 squared, which is 1 over 36. 1 over 36 plus 6, again, I'll have to get common denominators. So 6 is going to turn into, and when we get to number 9, there is a typo for the vertical intercept on this one. Here, if I were to type in 6 to the 0 minus 2, I'm going to get 6 to the -2nd. That's going to give me 1 over 36. 1 over 36 plus 6 is going to be much bigger than this. It's going to be over 6. It's going to be 6 and a 36th. So you could go ahead and convert that mixed number into an improper fraction, but again, that vertical intercept is wrong on this screen. For our zeros here, the zeros are going to be none. And the reason here that we can just say none is that this is positive. So as soon as we get a non-negative in this position, we're automatically not going to have any zeros. As far as increasing or decreasing, this is going to be increasing because our base is bigger than 1. And therefore, it's also growth. As far as our end behavior, if I know that this is going to increase over time, then the left side is going to go towards the asymptote, which we know is going to be at 6. And then the right side is going to go towards positive infinity. Again, that asymptote comes from this last number right there, therefore being f of x is equal to 6. Try the next two. For number 10, if I'm plugging 0 in for x there, I'm going to get 1/3 to the negative second. That's going to flip that fraction and make it 3 squared. 3 squared is 9, and 9 plus 3 is going to give me 12. So that's where that vertical intercept comes from. Then, because this is positive, I know that I'm not going to have any zeros in this one. Because this is a fraction, this is going to decrease over time, and it's going to be decay. Then from there, for my end behavior, again, I'm picturing what this graph would look like. So on the left side, it's going to point up, and that's why this is positive infinity. On the right side, it's going to go towards the asymptote, and that's why this is going to be at 3. And then finally, when we're looking for the horizontal asymptote here, that's going to be f of x equals, and again, it's whatever number we have right here. So that's a positive 3. And then for 11, here, if I plug in a 0 for x, anything to the 0 power is 1. So then I've got 1 minus 1, which is going to give me 0 here. That means that that's also going to be a 0 for this one if it's intersecting at 0, 0. Because that base is between 0 and 1, it's going to be decreasing. It's going to be decreasing, therefore decay. And then for this one, if I'm picturing what that looks like, on the left side it's pointing up, so that's positive infinity, and on the right side it's going towards the asymptote, which is going to negative 1. Asymptote again comes from, we can basically just get rid of this part right here, and it's f of x is equal to negative 1. So please complete the exit slip associated with this lesson, and your homework is in practice at 28.